Good morning, good afternoon, and good evening, everyone, wherever you might be. And today we're going to be talking about, well, last video we talked about dot products. Now we're talking about cross products. So yeah, let's just get started. So here, if we're given two non-vectors, it is useful to find a non-zero vector that is perpendicular to both of them. I still don't know why, I'm just new. Please bear with me. Cross product of two vectors. Okay, so we have two non-vectors, non-zero vectors. So we have A and B, and suppose vector C is perpendicular to both A and B. So what does that entail? Well, here we can see that the dot product of A and C is 0 as well as B and C is 0. Why? If we get the dot product of two non-zero vectors and their dot product is 0, then that means they're perpendicular. That's what it basically means. Okay, so yeah, so we did the dot product here. This is the dot product. So A1 times C1, A2 times C2, and so forth, B1 times C1, and they're both equal to 0. And here we can actually eliminate C3. So we're going to be taking this out, right? And how do we do that? Well, we multiply B3 to this equation here, equation 1. And we multiply A3 to this equation, equation 2. And we're going to subtract accordingly. And as you can see, we did multiply B3 in the first equation, and we multiply the A3 in the second equation, and voila, that. If we subtract this, that's 0. So we're left with this and this. 0 minus 0 is 0. Yeah. And then we can simplify, and we get this one. Right? Came from here. These are both C1, so that's A1 B3 minus A3 B1. That's where that is. And for C2, it's this one. A2 B3 minus A3 B2. So it's this one. And those are equal to 0. And here we can see that this equation, equation 3, I put numbers. Equation 3 has the form PC1 plus QC2 equals 0. So C1 equals Q and C2 equals negative P. Why? If we assign it to those, we would get PQ minus PQ equals 0, which makes sense, right? So if we do that, we have a solution that is C1, which is this, and C2, which is this, right? C1 is Q. Let's look at that. C1 is Q. What's Q? This is Q. C2 is negative B. What's negative B? This one is B. So negative B is negative of this one. And we can simplify that as A3B1 minus A1B3, which we can see here for C2. Okay, I hope I'm not going a bit too fast. All right, hope that makes sense. And now from here, we can actually substitute these values into equation 1 and 2, right? So if we substitute C1 and C2 to 1 and 2, so let's say, okay, let's look at equation 1. I should have just copy and pasted. I look at equation 1. Okay, take this out. Right. So we're saying here, substituting these values to equation 1 and 2, we got, so this one, and we're going to plug in C1, so that's A1 times A2 B3 minus A3 B2, the other way. This is long. And we have C2 here. So C2 is, okay, A2, C2, this is C2, A3 B1, A1 B3, plus A3 C3, which is equal to 0, right? That's what happens when you plug it in. That's equation 1. Equation 2 is going to be, where was it? Here we go. So I'm just gonna copy paste. Oh shoot, went here. Okay. They're making me work here. Okay, so that's equation 2. Oh, it doesn't work again. Uh-oh. Oh my goodness. All right, we're going to stop sharing first, restart my OneNote. Oh, I can minimize my Zoom. Oh. Okay, we're going to okay, perfect. Now I can go back. Okay, there we go. Hopefully this works. Yeah, I'm still having issues with the, when you switch the eraser and the pen. I don't know how you guys work that out. Because sometimes when I switch to the eraser, I can't switch back to the pen unless I restart my OneNote. But yeah, anyways, so we're going to substitute C1 and C2. So we have B1, and my C1 is A2B3 minus A3B2. So A2B3 minus A3B2 plus B2. And we have my C2. My C2 is A3B1 minus A1B3. So A3B1 minus A1B3. Great. And then B3, oh shoot, B3, C3, which is also equal to 0. So since both of these are equal to 0, we can actually equate them towards each other, right? We can do that. I think I messed up something. Wait a minute. Wait a minute. Oh, there we go. Plus A3, C3. Yeah. So once we equate these to each other, we will actually get a value for C3. C3 is A1B2 minus A2B1. And so what does that mean? This means that a vector perpendicular to both A and B is that vector C, right? So the goal here was we found components of C in terms of A and B. That first component, the second component, and this third component. So we actually found 3 of them, right? going to erase this because you already found both of them. We did the proving. Okay. Oops. My bad. So that's what this means. So I'm just rewriting it. This means vector A and B are what we call perpendicular to vector C, which has components C1, C2, C3, and we're going to write them in terms of AB. So we have A2B3 minus A3B2, right? Then we have A3B1 minus A1B3. And lastly, A1B2 with comma. A1B2 minus A2B1. Yeah, which is actually this one. Great. So that's the resulting vector. C is the cross product of A and B, right? And it's actually denoted by the symbol, this X here. Very original. Okay, so we're gonna go to definitions here. So basically the definition of cross product if A with components A1, A2, A3, and B with such components, then the cross product of A and B is the vector. So funny enough, it's a vector. That's their cross product. A x B or A times B or whatever. And it kind of looks like a multiplication. A2B3 minus A3B2 comma A was above here. A3B1 minus A1B3 A1B2 minus A2B1. So if you notice that the cross product of vectors A and B is a vector, but the dot product is a scalar. If you remember, the dot product was this, and this is A1B1, A2B2. Shoot. My mind is thinking one way, and I'm saying something else. And A3B3, right? That's the dot product, and that's going to be a real number, which is going to be a scalar. But here, when we do a cross product of two non-zero vectors, it's going to be a vector. And for this reason, actually, the cross product is also called a vector product. Very original. And we note that A x B is defined only when A and B are three-dimensional vectors. So this doesn't work in 2D. So this only works when A and B are 3D, which means they have a some change in X, some change in Y and Z. Doesn't work for 2D. So I think this will be useful soon. I'm not sure yet. I'm still in this chapter, but hopefully it's going to be useful soon. Okay, and here, in order to make the definition for easy to remember, we use this notation of determinants. Wonder what that is. Uh, Interesting. So it says here, I think we're just gonna write that out. So in order to make definition for one nose lagging, definition for easier to remember, we use the notation of what we call determinants. Right? So we have an example here. A determinant of order 2 is defined by, I'm guessing we're going to put some letters here. Okay, so we have A, B, C, D. And it looks like a matrix if you think about it. And we have this formula here, which is AD minus BC. So the idea is we multiply the diagonals and then we subtract. And actually, I think that's what we're going to be doing here. Right? So we get the product of this subtracted by the product of this. That's the idea. So for example, we have a nice example here. We have this matrix. So 2, 1, -6, 4. And this is the product of 2 times 4 because we want to multiply across diagonals. We're going to subtract the 2, 1 times -6, and we get 8 plus 6, we get 14. Okay, now I know it's order 2. I'm kidding, I actually don't know why. I think it's just because the number of rows and the number of columns are 2. Right? Now we're moving on to, we're gonna up it up a bit. We now have a determinant of order 3. So probably 3 columns and 3 rows can be defined by can be defined in terms of second order determinants. Right? What do I mean by that? Well, we're given this call it matrix. Because I did a bit of matrix before. Actually gonna be making a video with that, so stay tuned. Probably soon. A1, A2, A3. So now we're gonna use that example we had a while ago. B2, B3, and C1, C2, C3. Oops. All right. This is A1 of B2, B3, C2, C3. Right? Okay. we keep going. Minus A2. So what's the idea here? I'll show you guys in a bit. A2, so we probably have B1, B3. I'm gonna write the notation and explain it later. C1, C3. Oops. Probably should have done it on the other side. Yeah, I'll do the other side. Oh, okay, somewhere there. Then we're subtracting it again to A3. And this is B1, B2, C1, C2. The idea how this works, we get A1, and then we kind of delete the column. So A1, we take this out. Or we left with this one, right? So let's say this is like our headline-ish, right? So we just mainly focus on this one. We're going to be doing A1, then we take everything out from that column. Then we're going to be looking at this. That's the same as this, right? Next thing, minus A2. Now we remove everything from the A2 column. And now we're looking at this and this. So B1, B3, C1, C3. And then we're looking at A3. We remove everything. We have B1, B2, C2, C1, C2. Right? Okay. So actually, I'm thinking. No, I still don't know the relationship. I was trying to find like a connection, but maybe we'll see it later. Okay, so here we observe that each term on the right side of the equation involves a number, A, in the first row of the determinant. Oh, we call these determinants. Okay, cool. And A is multiplied by the second order determinant obtained from the left side by deleting the row and column in which A appears. So what we did a while ago. And we notice also the minus sign in the second term. All right, so we're gonna do an example where we solve these determinants. So for example, we have this determinant. So we have 1, 2, -1, 3, 0, -1. Oops, I meant 1. Sorry. And then we have -5, 4, 2. And this is 1. So again, we do that same format we did a while ago. So we're going to do 1. We get rid of everything in this column, right? So we have 0, 1, 4, 2. Right? Because we kind of think of this as our headline again. So we take out, let's say 1, we take this out. So we're left with this, which we're just going to write it up basically. Okay, minus 2, because that's our next one. We get rid of everything in that column. So we have 3, 1, -5, 2. Minus -1. Minus -1 means plus 1. So we get rid of everything from that column. So we have, okay, is it still recording? I hope it's still recording. Okay, it's still recording. Nice. Yeah, okay, that's fun. I just lost power in the middle of this one.